Welcome in our today's lesson, whereby we are going to find the forces in all the members of the truss shown in the figure below. It is a very simple truss in form of a triangle, and in this case it is a right-angled triangle that is loaded with a load of 5 kilonewtons at its apex. It is supported on its joints B and C with two supports, and these supports can either be columns, they can be walls, or they can be beams, either of them. The size or the length of member BC is 5 meters. The angles B and C are 60 and 30 degrees respectively. Now, the first thing we are going to do is to determine the length of member AB, and in finding the forces in all the members of this truss, we are going to apply the method of joints. Therefore, ladies and gentlemen, join me as we analyze this truss. If you are yet to subscribe to our channel, please consider doing so that we take this channel to the next level. Now, calculating the size of member AB, we are going to have AB being equal to 5 cos 60. The reason being, this is a right angle triangle, and we know that cos theta is usually given by adjacent divided by hypotenuse. This is the adjacent we are looking at, that is the side we are looking for, and this is the hypotenuse, and this will be equal to 2.5 meters. Therefore, we come to our member AB and we write 2.5 meters. Now, the next thing we are going to find out is the distance of the line of action of 5 kilonewtons from B. Therefore, the distance of the line of action of 5 kilonewtons is this point on the member BC. That is, dropping a straight vertical line all the way to member BC, that is going to be a perpendicular line at this point. Therefore, if we call this point E, the size or the length of BE, that is the distance of action of these 5 kilonewtons from B, is going to be given by 2.5 meters, 2.5 multiplied by cos 60, the angle at B, and that's going to be 1.25 meters. Therefore, the distance from B to E will be 1.25 meters. Now, after getting the sizes of members AB as well as BE, the next thing we are going to determine is the reactions. Therefore, the reaction at B as well as the reaction at C. So, we are going to calculate the reactions at B and C. Therefore, we got reactions calculations. Now, for us to get the value of the reactions at B as well as at C, we are going to take moments about B from C. Therefore, taking moments about B, we are going to have, so this is going to be RC times 5 meters. Remember, that is an anti-clockwise moment. Therefore, RC times 5 is equal to this clockwise moment, 5 times the distance from E to B, which is 1.25 meters. Therefore, is equals to 5 times 1.25 meters. To get the value of RC, we are going to divide both sides by 5, and This is going to give us a load of 1.25 kilonewtons. Therefore, the reaction at C will be 1.25 kilonewtons. Now, for us to get the reaction at B, we are going to apply the Newton's third law of motion that states that for every action there must be an equal and opposite reaction, and therefore the sum of upward acting forces must be equal to the sum of downward acting forces, and therefore we are going to have RC plus RB being equal to downward acting forces, and in this case the downward acting force is 5 kilonewtons. We got the value of reaction at C, which is 1.25 kilonewtons. Therefore, 1.25 plus RB is equals 5. And this is going to be, reaction at B is going to be 5 minus 1.25 kilonewtons, which is going to give us 3.75 kilonewtons, and therefore the reaction at B is going to be 3.75 kilonewtons. From there, we are going to go to calculation of the forces in different members of this truss, and we are going to consider two joints, joint B as well as joint C. Therefore, starting with joint B, when we consider joint B and we try to plot it or to sketch it here, we are going to have something like this. This is A, this is B, and that is C. At B, we have a reaction whose value is 3.75 kilonewtons. 3.75 kilonewtons. Angle ABC is 60 degrees. Now, let's assume that on member AB, we have a force F1. In this case, we don't know whether it is a compressive force or a tensile force. We shall know that after getting its value. On member BC, let's assume that we got a force F2. Now, resolving forces vertically, resolving the forces vertically and applying this principle of summation of all the vertical forces to be 0, we are going to have F1 sine theta, F1 sine theta, plus the reaction at B, which is 3.75 kilonewtons, is equal to 0. This means that the sum of all the vertical forces are equal to 0. And therefore, we are going to have F1 sine theta being equal to, taking 3.75 the other side of the equal sign, we are going to have minus 3.75. Now, theta is 60 degrees, and therefore F1 sine theta is the same as F1 sine 60 is equals to negative 3.75. Now, for us to get the value of F1, we are going to divide through by sine 60. Divide through by sine 60. And therefore, F1 is going to be equal to negative 4.33 kilonewtons. This negative means that the force F1 is compressive, and therefore this force is going to compress this joint B with a force of 4.33 kilonewtons. Therefore, we can ignore the negative and write 4.33 kilonewtons into bracket compressive force. Compressive force. Therefore, that is the value of force F1 by resolving the forces vertically. Then from there we go to resolving the forces horizontally. Resolving the forces horizontally and applying the principle of summation of all the horizontal forces being equal to 0. Now, horizontally, we are going to have F1 cos theta plus F2 is equal to 0. Therefore, horizontally, we are going to have F1, this is a force F1 cos theta, plus this force F2 being equal to 0. Sum of all the horizontal forces. Now, we got the value of F1, which is negative 4.33. Therefore, when we substitute it here, we are going to have negative 4.33 multiplied by cos 60 plus a force F2 is equal to 0. Now, negative 4.33 cos 60, that is going to be 2.165. Therefore, negative 2.165 plus F2 is equal to 0. Now, bringing negative 2.165 the other side of the equal sign, we are going to have F2 will be equal to 2.165, which is a positive force, and therefore the force F2 is going to be tensile, because positive forces are usually tensile forces, and therefore it means that the force F2 is acting away from joint B. Good. So that is all about joint B. Now, after analyzing joint B, we are going to go to joint C, analysis of joint C. So, we write there joint C. Now, what do we have on joint C? For joint C, we have the following. Try to sketch it here. Yep. We have A, that is joint A. We have B, and we have C. Now, at C, we have a reaction whose value is 1.25 kilonewtons. Therefore, RC is equals 1.25 kilonewtons. So, again, we are going to have a force F2 on member BC, and on member AC, we are going to have a force F3. The angle ACB, that is 30 degrees. Likewise, we are going to begin with solving the forces vertically. The forces that are acting at joint C. Therefore, dissolving the forces, resolving the forces vertically, and applying this principle of summation of all the vertical forces being equal to 0, we are going to have the following: F3 sine theta plus the reaction at C, which is 1.25 kilonewtons, will be equal to 0. That force will be given by F3 sine theta. Now, F3 sine theta, and in this case theta being 30 degrees, plus 1.25 is equal to 0. So this is going to be F3 sine theta, that is sine 30, being equal to negative 1.25. For us to get the value of F3, we are going to divide through by sine 30. Divide the other side as well by sine 30. And therefore, F3 is going to be negative 1.5 divided by sine 30. That is going to be 2.5 kilonewtons. And therefore, F3 is equals negative 2.5 kilonewtons. Whereby, negative 2.5 means that this force is a compressive force. That is, the force is compressing the joint C. And therefore, if we ignore the negative, we can write it as F3 is equals 2.5 kilonewtons into bracket compressive force. Compressive force. So that is the analysis of the forces vertically. After analyzing the forces vertically, the next thing we are going to do is analyzing the forces horizontally. Therefore, analyzing the forces horizontally and applying this principle of summation of all horizontal forces being equal to 0, we are going to have, let me create more space at this point. Good. Therefore, we are going to have F3 cos theta plus F2 is equal to 0. Therefore, a horizontal force here, a force of F3 cos theta plus this horizontal force of F2, we are going to have that summation being 0. Now we got the value of F3, which is negative 2.5 kilonewtons. Therefore we substitute it here, negative 2.5 cos that plus F2 that we don't know is equal to 0. F2 will be equal to 2.5 cos that. Taking 2.5 cos that in the other side of the equal sign. And therefore 2.5 cos 30, that is going to be 2.165. Therefore we got 2.165 kilonewtons, and in this case that force, since it is positive, is going to be a tensile force, and therefore that is how we determine, or that's how we find the forces in all the members of this simple triangular truss. Now, if we write those forces in all those members, in member AB we have a force F 1, whose value is 4.33 kilonewtons. Therefore, you have 4.33 kilonewtons, and that is a compressive force. On member BC, we got a force F2, whose value is 2.165 kilonewtons. That is a positive force, and in this case it is going to be a compressive, a tensile force. Positive forces are tensile forces, therefore that is a tensile force. Finally, on member AC, we got a force F3, whose value is negative 2.5 kilonewtons, and therefore, since that force is negative, it is going to be compressive. Therefore, we got the forces on all the members of the truss. So, ladies and gentlemen, thank you for watching our video. If you have liked it, please consider subscribing to our channel. Hit the notification bell so that you always be the first person to be notified every time we post a new video. Thank you very much. Let's meet in our next